Welcome back to the anatomy of a Minecraft model, lecture number 3, blocks and items. So before the break we took a look on how we can render items. We used the same model that we used before for the entity itself, and we made sure that that was rendered in the hand or on the ground, you know, when we dropped it and so on, in the inventory, etc. And that's pretty much everything we're going to go through for the items. But what we're going to take a look on now is the blocks themselves. So how do we render blocks, and well, how does that work? And we're not going to use any models here, even though the course itself is called the anatomy of a Minecraft model, because the blocks works a bit different. You don't use these model base, you don't use model renderers and model boxes, you don't use those when it comes to blocks. So we'll take a short look on what we can do with these guys and how all of those things work. And well, it's obviously going to take some time if I just need to set up a simple block that we're going to use. So the block I'm going to modify and work with is a block that we've been working with before, the block machine. We've used it in Forging Minecraft mod as well as climbing the interface ladder. It's basically a block that, well, can drop anvils, we can activate it and disable it and so on. But it doesn't really matter for what we're going to use it for. We're basically just going to change how it is being rendered and so on. So what I want to do first is do simple things. I want to set which size it should have. Which size should this have? Usually you have a block of a size 1, I guess, you can say, from 0, 0, 0, which is one corner, to 1, 1, 1, which is the opposite corner. So to do so, what I want to do is use set block bounds based on state. That's the first one. And we don't need this one there. But what we have here is X, we have Y, we have Z, and we have the world. So we can basically get the metadata there, or we can get the, you know, the tile entity or whatever, and we can use that to define its state. Well, sort of it bounds depending on the state, sorry, because, well, that's what it means. We can get the metadata and use that to define the bounds and so on. So what I'm going to do is exactly that. If world dot get block metadata like that equals, well, get it first like that, if that mod 2 equals 0. So if you haven't seen previous lectures, well, previous courses rather, then you don't know what this is checking. But basically what we're doing here is checking if this machine here is active. We can disable it, but if the metadata mod 2 equals 0, that means that it is active. So that's what this if statement is checking, like so. And then we can do something else here. So if it's active, what I wanted to do is just use the normal size. So set block bound, so that's how you set the size here, 0, 0, 0, 1, 1, 1. But these are floats, so we can add an F after each one like this. So like I said, a normal sized block is from 0, 0, 0, that's one corner, to 1, 1, 1. So the 1, 1, 1 is not the size, that's the other corner. So we'll see that in just a second. But now we just set the block bounds like that. And the reason why I use set block bounds based on state is because I want it to be different depending on, for instance, the metadata, like so. If I didn't want it to be different, then I could just set it once in the constructor and it would be alright. I could just set it like, alright, 0.5, there we go, done. This would basically make me a top slab. All of this would make me a top slab, nothing more. Now we have a top slab. If we want a normal slab, then we would swap it around, so we get 0 there and 0.5 there. So obviously if we have a slab that we don't want to change depending on the metadata or anything, then we would simply do it like that. But because I want to change it depending on the state, I'm going to put it here. So if it's active, then we want a full block. If it's not active, what I'm going to do is set block bounds. I give it 0.25f, 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 0.75f, 0.75f, and finally 0.75f again. And what this means is that we start quarter of a block from that side here, and then we start a quarter of a block from the other side, like that. So what we have left is a block that is half the size of the normal ones, but since we start at 0.25 and end at 0.75, it's also in the middle. So we have a smaller block that is just placed in the very middle. So this is not going to be enough to make it work properly, but we'll take a look on that in just a second. So let's see how this looks like. Here we go. Okay, it's night. Time set day to just allow us to see it a bit better. There we go. So what I want to do is grab the machine. I think they are here. There you go. Silly machine. And now if I place it, we'll see that it looks like any other block like we had before. But if I hit disable here in the interface, so the interface here that we created in the last course, I will see that it's going to get much smaller, like that. It's a half a block there. But the rendering is weird. We can see right through it like that. So that's not good. Another part is the collision. Depending on the block we're at, you can see I'm going right through it at times, and that's because it thinks that this large one at some times might have a small collision like this. So it's going very weird when I try to jump on it. And we'll fix both those things, both this rendering thing here and the collision not working properly. So what I want to do for the graphics thing there is to do the following: is opaque cube, and here we want to return false. And what that means is simply this block is not covering the full block, well, the full bounds of the block. It's not having 0, 0, 0, 1, 1, 1. And that means that you might have to render the sides of the block that it's adjacent to, even though they are sort of connected. You know, if we have two stone blocks next to each other, then obviously we don't have to render the faces in between there, because nobody's going to see that because the blocks are covering it anyways. So to reduce the amount of things we have to draw, because, well, we obviously have a ton of block in the world, and that's why we're trying to make, well, Minecraft is trying to render them as efficient as properly, well, as possible. Sorry, I can't speak it right now. So what we want to do is just tell it, well, we're not going to cover the whole thing, so you might want to make sure to render the sides around us just to make sure. So that's the first thing. That's just the rendering part. The other one with the collision, well, we have to tell it a few things. For instance, the selection. When we select things, or well, when we look at things, we get this little border around it. And when we do so, what we want to tell it is to update the bounds before it actually calculates that. So what we want to do is override get selected bounding box from pool, and that is how it selects or gives us the border when we look at things. For instance, if we look at the big block, we want the border to work on the full block, but otherwise, if we have a small block, we want to be able to look past it, otherwise, you know, with the selection, so we can click past it and so on. And to do so, what we'll have to tell it is set block bounds, where is it? Based on state, there we go, and give it the world. Oops, yeah, we had all of those already. World, X, Y, and Z, like that. So what we're doing here is nothing special. We just make sure that before it's actually doing the calculation, which is going to do anyways, that's this part here. So we tell it do the normal calculations, but before you do the normal calculations of the selected bounding box, then we want you to update the bounds depending on its state. So we'll have to tell it that one. So therefore this method is going to be run, and it's going to set the bounds properly, and then when it has set the bounds properly, those new bounds will be used when we calculate the selected bounding box, like that. And it's the same thing with two different methods, so I'm not going to bother about typing those. What we have here is this one, get collision bounding box from pool, and we're doing the same thing. We set the block bounds based on state first, and then we tell the superclass to do the normal collision code like that. And then we want a third one like this, which is the collision ray trace. I need to import those things, so Control-Shift-O, and there we go. So the same thing with all these things. We are set the block bounds based on state, and then we do the normal thing by calling the superclass, so just to make sure that everything is being updated properly. If we take a look now, we'll see that it should work properly. Here you go. And if I load it now, we should see that it's not ringing like past the wall, because we do everything, and it's a bit dark now just because, well, we had some problems before, but if we just update everything here, it's going to be rendered properly, and the collision will work properly, but I can't get up there. There you go. So it was too high for me to jump up on like that. There we go. So now they are smaller, these guys that should be small, and the other ones are bigger like that. There we go. Sweet, it's working. But we can see a problem. Look in my hotbar. Look at that item there. It's just blinking back and forth. And that depends on which item I rendered the last time. The way these bounds work is we set them, right? We set them and then we can use them. But as you might remember from earlier, from course 3 or whenever you learned about Minecraft modding, blocks are not, well, we don't have multiple blocks. We just have one machine block. We have one grass block. We have one stone block. We have one crafting table block, and so on. So if we modify the state of that block, then it's going to change for all the blocks. And that's exactly why we need to make sure to update it when we want to use it. And that's exactly what we're doing here. We tell it to update before we use it. But the thing that happens for the item is, well, we don't update it there before we use it, and that means that the last time we updated it, it's going to affect how it looks like in our inventory. So if I look at these small blocks, then that's going to be the last time I use it, because it's trying to check, oh right, you're hovering over this block, you know, the border there appears, and therefore the item in my inventory is going to use that, because that was the last thing we used. However, if I look at the other one, it's going to use the big one, just because that's the last thing I used. Or if I look here, that's also going to be the last thing I used, unless I put a small one over there, then that's going to be the last one that was being rendered, because it rendered them from that direction to this direction. So it's basically going to be very weird, depending on what I look on, basically. So, well, obviously we'll have to update it there as well, and it's fairly simple. What we'll have to do is override a method called set block bounds for item render, and here we just set the states here. And what I'm going to do is just tell it, well, you can use the normal size when you render it for you know, in the inventory, even if it's disabled. We could, of course, do it differently, but we can't really access any information. As you can see, we don't get any parameters with like metadata or anything, so we can't really do too much there. We'll just have to give it a state like so. So I'm just setting, well, do that as a normal block, and that's totally going to work. We can take a quick look. So what if we want to change the size depending on the metadata and so on? Well, it's a bit troublesome, but we can totally do that. But what we're going to have to do, as you can see now it's always big no matter what I do. But what we'll have to do then is register our own renderer, block renderer, I think it's called, that's going to render this for us. And we're going to use that, but we're actually not going to use it to render the item here differently. But we'll see how we can render the block that we have placed differently depending on what we want to do. So that's the next step, to register our own renderer for this block and then use that. And to do so, we obviously need to create this thing. So I'm going to create a new class here called, I don't know, render machine might make sense for the block machine. There we go. And it's the same thing as when I render the items. What I want to do here is implement an interface, but it's obviously not the same thing. What we want here is simple block rendering handler, like that. And if we just add unimplemented methods, we will see that we get render inventory block, render world block, should render 3D inventory, and get render ID. We'll ignore most of these for now, but we are going to use them later on. What I want to do first here is create a constructor, public render machine, like so. I don't care about any parameters for that, but what's important here is to have a field here that I'm going to call ID, that makes a perfect name, because what we want to do is when we create this, we want to get an ID for this simple block rendering handler, because we want different IDs so we know what to render, when to render it, and so on. So ID equals, and that should be rendering registry, like that, and then we can just do get next available render ID. We don't have to do that, but if you don't, you're just going to mess things up, because then we might use the same ID as some other mod, and so on. So it's just best to ask for the next available render ID, and then we just store it there. And the last thing that we'll have to do is then just to return that. So we just do return ID like so. So that's what get render ID should return, the ID that we currently have that this rendering thingy is using, and that should, if you do it properly, just be the next available one there. So just grab that from the rendering registry. So it's very easy, no ID conflicts or anything. So it just asks for that and everything works. But obviously we're not going to, well, render the machine with this render machine thingy unless we implement that part as well. And to do so, we should head over to the client proxy, like, well, all the other rendering thingies that we are registering. So what I want to do here is, well, a few things. First of all, I want to create a rendering machine, obviously. Render machine like that. Machine render, just a place to store it. New render machine. There you go. And then when we have that, well, import it as well, I guess, then we want to register it. Rendering registry dot register block handler like that, and then we give it machine render like that. Yeah, whatever I will call it there. And what that's going to do is basically register this handler here for, well, whichever block that wants to use it. So as we can see here, when we register the entity rendering handler, we give it a class like this should be rendering. Well, this class should be rendered with this new render droid. For items, we say, all right, this ID should be used to render this droid here. But here we don't do that. We don't have to do that. But we will have to do another thing. We have to store the ID of this machine render and then refer to that one. Okay? So what I want to do is head over to, well, somewhere that I can store it. And I'm going to store it in block info, where I store all the other like infos like IDs of things, their names and so on. So what I'm going to do is add public static int and call it machine render ID like that. And then I can just refer to that over here when I do machine sorry, I need to obviously refer to block info dot machine where is it, render ID like so, and that should obviously be the ID that we have for this machine render. So get render ID like that. So we just store that so we can later refer to that, and that's exactly what we want to do. If we now head over to the block machine, we can define that we want to use that renderer for this block, and we need to do two things. First of all, we should override render as normal block, and what we want to return is false. So this is not a normal block anymore, it's a special block. It should feel special, I don't know why, but there we go. So it's not a normal block when we render it, and then we also need to define how do we render it. Well, get render type, that's the thing we want. And what we want to return is return block info dot machine render ID. So that's how it works. So what we're doing is that we tell it, well, you're not supposed to be rendered as a normal block, but you're supposed to be rendered using this ID here. And the reason why it then works is because the render machine that we've set up is returning the very same ID, and that, well, render machine has been registered. So when we give it that ID, it's going to look for in the rendering registry, it's going to look for the correct, well, the rendering handler with that ID, and therefore when we return that for the block, then what's going to happen is that it's going to be rendered properly like that. So let's give it a try and see what's happening. Obviously we don't render anything at all. Look at this, we don't render anything, but just let's just take a look and see if everything is being registered properly. Right, there we go. So if everything works alright, we should see a lot of things, which seems like a very bad way. Yeah, but here we go. We have these blocks here. We can still collide in them, but obviously we don't render anything for them, so it's a bit weird there. And as you can see, the item now is rendered, well, just rendered as the icon, the top icon, so that's also a bit weird. But we can still use it, but you know, we don't render anything. But as we can see, the registering part is working, and that's one first thing that we need to make sure that it is working, because otherwise it's obviously not going to, well, show up as anything. Okay, what we want to do here when we render it is return true to tell it that we actually did render it something. And what we want to do is simply refer to the renderer, that's this one here, the render blocks. And this render blocks thing here is what's being rendered, well, what is rendering all the different blocks in vanilla Minecraft. So if you want to take a look on how they do it, just open that one. But beware, the render blocks class is the longest class in the vanilla code. It's 8,000 lines long. So you have a lot of information inside this class here, but that's also a bit of a bad thing, because it might be tricky to find what you're looking for. But if you, well, look for a bit, you might find what you look for there. So if you want to know like how is the bed rendered, then you can search for bed there, and you will find the code for rendering the bed, and so on. But we'll use this to render the whole thing, because it's going to contain a few methods that we can use. For instance, render face y position, well, y positive, sorry. And what we have here is 6 faces, as you can see, and those are the 6 faces of the block. And as you can see, we have x negative, y positive, y negative, y positive, c negative, and c positive. And I want to render the top face, and that's obviously y positive, because that's up towards the sky. So that's the one I want to use. And now I need to give it a few things. I need to give it a block. That's an easy one. That's just the block we get here. Then the coordinate, and that's also an easy one. That's just the coordinates we get, x, y, and z, like so. And then the last part is the metadata, or well, rather the icon from the metadata that I'm going to get. So we want the icon here. So I do block dot get icon, and I'm just going to use the top there, and finally get the metadata here. Get block metadata x, y, z. So it don't really have anything to do with metadata. I said wrong there. But what we have here is simply an icon. We can get it from anywhere. We can just define it like an icon that we have registered somewhere else entirely. Or as I'm doing now, I'm actually just grabbing the correct icon from the top of the block. One means the top, and here's the metadata of the current block. And by using get icon there, we're going to get that one. Maybe we will want to do well, use some other methods like block.get, what is it called, block texture, I think. Block texture, yeah, we can use that one as well if we wanted to. Maybe that would be better. So we used the world here, and x, y, and z, and so on, and so on. It's basically a way of getting the icon. At the moment, what I'm going to do is just do block.get icon, like so. So let's give it a try and see what the result will be. There you go. And what we should see is the top face being rendered. We shouldn't see any other parts of the block being rendered like that. So we can see the small faces here, we can see the big one there, and if we take a look from below, we won't see anything at all. But as you might have realized, it's green. Why are they green? And why are they grey now? Well, basically, many different blocks can change the colors when rendering things. So for instance, the grass blocks changed it to green, and you know, therefore we would have to reset the colors to make our block look properly, because now it's just changing colors depending on what we put next to it, like that. So to do so, what we want to refer to is the tessellator. So this is the first time we're going to see the tessellator, and the tessellator is basically what's rendering it all. It's referred to a lot in the render blocks here. We've used that before without knowing it, like when we work with models and items and so on. But when we render the blocks in our own way, we're going to use it directly, whereas otherwise we won't actually see that we're using it. So that's just why this is the first time we will see it. And what we want to do is set color opaque F like so, and just do 1F, 1F, and 1F, and that's going to reset the colors, which makes sure that we actually render this icon like we want. And that's actually everything for now for the rendering part in the world. We'll take a further look on that later on in the lecture, in the very end of the lecture. We'll continue with here. But before I do so, I want to cover how to render things in the inventory properly. And as you might have seen, or well, as you should have seen, in the hotbar, in the inventory, what we saw was just the icon of the top. And that's because we return false here. And if we return true, you might expect, well, then it's being rendered in 3D, right, like we had before. No, that's not the case. What will happen is that it will call render inventory block, and here we can define ourselves how it should be rendered. So we will have to define how you render it in 3D. There's no easy way to do it really when we define it here. But what we want to do is head over up here, of course, modify that, and just start. And the first thing to do is to set block bounds for item render, like so. And as I discussed earlier, when we had the block and set the state of the item, or well, state of the block depending on the item, so we just set it to the default size. I said, well, we can't really set it to the smallest size depending on the metadata because we don't have it. Well, when we do render it ourselves here, then we actually do have the metadata. So if we wanted to, what we could do would just be to use that like so. And this is basically the metadata from the damage value. So if we wanted to, we could set the block bounds for item render depending on metadata if we created that method ourselves. But for now, I'm just going to use the same size as before, which is the one full block that we had before. So that's the first step. We just set that for the block. But then the next step we have to do is to refer to the renderer. You know, this render blocks, that huge file, and then set rendering bounds, or we'll set render bounds, and that's what we need. But we can just refer to this one, set render bounds from block, and give it the block itself. So then it's going to grab the size of the block and the location of the block and so on, and apply that to as its current render bounds, basically. And we need to do that so it renders everything properly. Right, then we need to do a few other things. We need to start the drawing, and to do so I'm just going to do gl11.glpush matrix. So when we're done here, we won't have caused any mess that will remain. So we just push that, and then in the end we pop it again, like we've seen before when we rendered the entity, when we rendered the entity in an interface, when we rendered the item, and so on. So there's nothing new here. We're pushing the start and popping the end, like that. And what I want to do is just to apply some rotations and translations to place the item properly where it should be. Why should we use these? Well, that's just how the rendering works. We need to move it a bit and rotate it a bit to place it where it should belong. And this is exactly how it's made in the vanilla 3D block. So we need to rotate it by 90 degrees, and that's in the Y direction, like so. So we just do 0, 1, 0, like that. And then we need to move it a bit as well, and that's going to be minus 0.5f, minus 0.5f, and minus 0.5f. So that's just what we have to do. Before we do the rendering, what we'll have to do is just rotate it 90 degrees and then move it a bit like that. And that's just so we place it where it should belong, and then basically we're done there. So it's rendered in the center and so on. So that's just what we'll have to do. The next step, what I'm going to do is refer to the tessellator. But when we do this code here, we're going to refer to the tessellator quite often. So one thing we might want to do is just do tessellator equals tessellator.instance, like that. And what that's going to do is basically so we can refer to it without having to refer to tessellator.instance each time. Sorry. And what I want to do here are 4 things. We need to tell the tessellator to start drawing. And we do that like this. Tessellator dot start drawing quads. So what we tell it is that it's going to start the drawing process. We're going to apply things to it to define how it's going to draw this, and then we tell it to draw. And the quads here is simply sort of a rectangle and that we want to draw. And what we'll have to give it is like, oh right, you should start here. When you draw things, you should have this corner and that corner and that corner, so we give it 4 different corners, and then we'll also have to define, alright, you should grab the texture from this texture here, and from that texture should have these 4 corners, and so on. So there are quite a few things we'll have to define after we have done start drawing quads, but we'll see that we don't have to bother about that ourselves. We can ask the renderer here to do most of those things. Okay, the next thing we want to do is refer to the tessellator again and set normal. 0f, 1f, 0f. So this is basically defining which direction this is going to be rendered in. So we tell the tessellator, the normal direction is this, so then we get 0, 1, 0 there, because we want to render the top. That's what I'm going to render. I'm going to render the top of the block here. If we would like to render the bottom of the block, then what we want to do is have -1 here instead. And the sides, we will go 0 here and maybe 1 here, you know, or 0, sorry, -1 there, or something like that. But since we want the top one, I want to add 1 like so, and then it's just a matter of rendering the top face, and we've done that before. So renderer dot render face, and we go y positive like we have down there, so it's the same thing, but the block is the same. And what about the position? Well, you know, there you go. Let's go with 0, 0, 0. We shouldn't add a specific position because we obviously don't have one. So go with 0, so it's placed where it should be, and everything will work fine. How do we get the icon? Well, we can just do block.get icon like that, and then 1 and metadata. So we have the metadata already, so it's just a matter of referring to that like so. There you go. One last step, and that is obviously to, what is that? Well, to draw it all. Like I said, we wanted to prepare everything, but then when we're done, we obviously tell the tessellator to draw it in the end. So quite a lot of new things here. We work with something called a tessellator. We tell it to start drawing the quads, set the direction, but all the advanced stuff is already taken care of in render face y position like that, and therefore we can just do that and then tell the tessellator to draw. We'll take a look on how this looks like. Rightio. There you go. So it looks good there. Oh, well, it looks the same with the colors properly and so on. But here we go. We have the still machine here. If we hold in the hand, it's just the top there, because that's the top we're rendering. That's the only part that we are actually rendering there. There we go. Obviously it doesn't look that well, but it's the top indeed. And if we want to add a rest, we can just add them one by one. So if we want a bottom, I'm going to add it here. Then we have very few differences. I'm just going to copy it here so we don't have to type a lot. We start drawing the quads like that, and in the end we draw it as well. Okay, we set it normal, but like I said, we use -1 rather than +1. And then instead of rendering the positive y, we render the negative y face, and instead of using 1 here as the side, well, as the side when we get the icon, we use 0 there. So we have 3 differences. We set the normal differently, we refer to another face rendering method, and we use another side when we get the icon like that. So nothing else than that. And then we can just do that for all the different sides. So I'm going to add 4 more sides here, and they do exactly the same thing. So here we're referring to some other values when we set the normal, we refer to another side when we get the icon, just because we want different icons, you know, and we render another face like that. So if we do it like this, we're doing it pretty much the same as vanilla does it when a block is being rendered in the you know, in the inventory as an item. So let's take a look on how the end result is, and it should be very familiar. It should be just a normal block if everything went all right. That is. Rightio. And boom, look at that. It looks like a proper block, and there you go. Not a problem at all. It looks like a normal block, and that's pretty awesome. But like I said, now when we have it here, we can do more advanced things. We don't even have to do it like this. We can make it draw it differently, or what we can do is set the bounds differently. Now we get the metadata like that. That's awesome. So we can do different things depending on the metadata, so it's being rendered in different sizes and so on. Or just control it all together. We can make it spin or whatnot. That would be a bit weird to spin it in the inventory, but we could totally do that if we wanted to. So that's everything I'm going to cover for rendering it in the inventory here. What we of course also could do is use an item renderer and render it as a model, because, well, in the end, what we have is well, we have a block, and each block has an item, and that's the item we want to render, and we can just, you know, add an item renderer to that, and therefore we could render the item itself in some way, and then the block still with this rendering, the iSimple block rendering handler. But if you want to render it as a normal block, we can just refer to that there in render inventory block like that. So what I'm going to do now in the end is something I mentioned already, and that is to improve the looks of this, because it's pretty silly to just render the top face there, and I'm just not going to tell it, well, render all the other faces. That's just going to be boring. So what I want to do is render this so it's going to look sort of like, I don't know, sort of a table, I don't know. So I want a top slab and then two sort of sides that is carrying this top slab basically. And how do we do this? Well, we have the block and we have the renderer, so we can just tell it how to render things. So what I'm going to do is just say block, set block bounds, so I can set the bounds, okay? 0, 0, well, 0f here, 1f and 1f. So what I've said now is that the base is going from 0, 0 to 1, 1. That means that if we look at it from the top, it's going to be looking like a full block. However, I want to change the size, well, the Y size and Y position a bit. So I wanted to go all the way to the top, right, that top slab, but I wanted to start at 0.8. That means that it's going to be a thin top slab at the very top of the block. So far so good, right? We just set the block bounds like that, and then when we set those block bounds, what we can do is refer to the renderer and set rendering render block bounds and just use the block there. So what we're doing here is exactly the same as we did at the top of render inventory block, that we set the block bounds and that we set that for the renderer as well. But when we work with the well, the render inventory block here, we refer to set block bounds for item render. But if we open the declaration here, what we did in the end, well, right, it referred to the normal block. If we take a look in the block machine rather, then we see that set block bounds for item render, the only thing that does is set the block bounds like that. And then if we go back to the render machine, we can see that that's exactly what we do. We refer to the block and set the block bounds, and now we do renderer.set render bounds from block. However, when we render the world block like this, we can use some methods that are much easier than just rendering face by face like we do here. And what that is going to be is the following. So we can do renderer.render standard block, and then we just give it a block and the position. There you go. We can't use these methods when we render the item up here. We don't have enough information for it to be rendered properly, so unfortunately we can't tell it just render a standard block like that. But this is basically how you render a block if we haven't defined anything special. So if we would where is it? If we would remove this part so it wouldn't use any special rendering, in the end what would happen would just be that this would happen. It would render it as a standard block. But what we're doing now is that we set the block bounds and just update that properly and then render it as a standard block. But we're not done here yet. What I want to do is obviously add more things. We have the top slab, but I wanted two sides as well. So what I'm going to do now is just block.set block bounds, so I can start adding well, another modifying the bounds and render it again, so I can render it multiple times to give it a more advanced shape. And this is sort of how you can do with stairs. You know, when vanilla stairs, they have obviously different paths and they have different blocks to make it look like a stair, and this is how you do it. You set the block bounds and you render it and so on and so forth. If you wanted to make it a bit more advanced, then you can code it a bit well, better, I guess, but this is the basic way of doing it. You set the block bounds, you set that for the renderer, and then you tell it to render a standard block. So just those 3 steps. So what I want this time is for it to go from 0, 0, 0. I want the width to be 1, and I want it to go all the way up to the top slab. So the top slab obviously starts at 0.8, and therefore I'm going to tell this to go to 0.8 like so. What do I want with this one? Well, basically, the side should have width as well. It shouldn't go all the way at the bottom. And I want it to be at one side, so therefore I think it should go from 0 to 0.2, like that. What's the next step? Well, just copy these 2 lines. Boom, done. So what we do is update the rendering bounds and then do the rendering. And then the last thing I want to do is set the last side. So block.set block bounds like before, and I want sort of a similar thing here. I want 1 there, I want 0 here, I want it to go to 0.8, so it goes all the way up to the top, and it should start at the bottom. But this is obviously the other side of this sort of table looking structure. So what I want to do is, instead of going to 0, well, from 0 to 0.2, I want to go, from 0.8 to 1, and that means that we have the opposite side. So here we have 0 to 0.2, so that's 0.2 in width, I guess, or depth or whatever, and here we have the same thing, so 0.8 to 1 instead. So that's going to put it on the other side. And now if we put these 2 things there to, well, update the proper bounds and then set the standard block like so, then what we can do is simply run this and see how it looks like. And this is basically going to be the end of the lecture. The last thing with here. Right, there we go. So now we can take a look on the result. How does it look? What does it look like? And hopefully it should look better. So there we go. It has a top and it has these sides. Obviously the textures are not made to fit this, so it might look a bit weird, but I think it looks fairly good. Not perfect, but it still looks pretty good. The top, of course, looks different, but as you might remember, we set the bounds of the whole thing depending on you know, the collision and so on. So these disabled ones still have a messed up selection here because I changed that one like so. So they still just have this small selection box like so. If I enable it, it will update the texture, and now it will have a big selection box. So obviously you will have to modify that to work properly. We can also take a look if we use one of these cards like we had before and right click here. It's going to update the textures properly, because when we use the render standard block, it's going to use, well, obviously the standard icons, because we try to render a standard block, so that's why it looks like it does. So a very simple block here, but that's pretty much everything for now. In the next lecture we'll take a look at how we can import block models and so on with object files and see how we can render those. But before we end this lecture, I'm just going to have a short summary of today. Right. So in the beginning of the lecture we started with items. Obviously render droid item here implements item renderer, which means that we can start render the items here. And what we wanted to do in render item, which was one of the methods, was to, well, render the model there. We had a model, and in the end we did model.render and then gave it null 0 0 0, yeah, you know, and then size. And before that we bind the texture as well. But as we also saw, this didn't really work properly. It would probably work better to give it some default values and so on, like we did later on. But when we have a item renderer like this, we have to register it here. So we created a model and gave it to it when we created a new render droid item. But the important part is obviously to do Minecraft Forge client.register item renderer and give it the ID. if we subtract the ID with 256 when we load it to make it fit the IDs of the items themselves, we need to make sure to increase it by 256. If you don't do that in the config, but you do that instead when you actually create the item, then you don't have to modify anything here. Then we saw this part here that we actually got which type of which type of rendering we did, if we rendered it in the inventory as an equipped item in the first person view, or maybe even if it was dropped, or maybe even as a map in some cases. And we can do different things depending on these when we render, and in this case what I did was just to move them along a bit to make them fit better where we wanted them to be drawn, basically. Okay. Then what we could do with those types would tell it when it should be rendered. Like this, if it's in the inventory, then maybe we don't want to render it there. So in this code that we can see in there, the method there, what it tells us, well, if the type that we get is the inventory type, then we return false, and if we return false, then we're going to use the default rendering for this item, which is basically going to be the one with the icons and so on. But if we return true, then we're going to use this item renderer, and if we always want to use this item renderer, then you can just return true. And then we can also define which helpers to use, and in this case I have disabled the entity bobbing and the entity rotations, which make sure that the dropped entity is not going to spin, nor it's going to bob up and down. So you can just return true depending on which helpers you want to use there. And then we went over to the blocks. So here we have a very simple thing here that we set block bounds based on state, so we can modify the size here depending on the metadata. So they are set it to default size if it was active, or if it was inactive we set it to a block that was just half the size but in the center still, by going from 0.25, 0.25, 0.25 to 0.75, 0.75 and 0.75, like so. So that's just the bounds there. But to make sure that everything around it will render properly, we had to set is opaque cube to false, like that, so return false. But that wasn't enough. We wanted it to be rendered a bit more advanced, so therefore we could use simple block rendering handler like that, and that allowed us to handle the rendering a bit further. But to do so, what we had to do was get an ID and then return it as its render ID that we can see there. So we set ID to rendering registry.get next available render ID. And then we use that in the block itself. We said render as normal block and return that as false, and then when we return the get rendering type, we simply return it from the the value we stored. So block info.machine render ID is obviously not enough. If we don't store it, we have to store it from the ID that was used by the renderer there that we created in the client proxy. So we just need to make sure that those IDs match. Here we had some rendering for the blocks that we put in the block rendering handler, simple block rendering handler. And that is exactly what we saw here in the very end. I'm drawing 3 blocks. So what we do here is update the bounds in the renderer after we set the block bounds, and then we render the block. So just 3 steps there. Set the block bounds, update the bounds in the renderer, and render the blocks. 3 steps for each block we want to render, but then I repeat that 2 more times to render 2 more blocks. So we got the top slab and the 2 sides, and we didn't care about defining the icons ourselves, so we just used render standard block, and the renderer took care of all the rest. But that's pretty much it for today. Don't forget the questions and exercises document. You have the questions to see if you've learned the things from today, and the exercises to practice those things. Then we have the further explorations if you want to go a bit further with those things, and finally, of course, answers and possible solutions to the questions and exercises. But that's pretty much it. This has been the anatomy of a Minecraft model, lecture number 3, blocks and items. I've been VSWE, and I've hoped you enjoyed it. Next time we'll take a bit short look on modeling softwares, 3D modeler softwares. We'll start with Techni to see how we can make Minecraft models through there, and then we'll take a look on how we can load object files as models to blocks, for instance. I will not show you how these work, like how do you work with like Blender or Maya or anything like that. You will have to do that somewhere else, learn that somewhere else, but I'm going to show you how to implement that into Minecraft. So that will be next time. I hope to see you then. Goodbye.